In this chapter, we are going to be discussing measurement, and we're going to start first by focusing on few skills that you need in order to succeed in Chem 10 and be able to do Chapter 2 at least. In chemistry, we're going to be working with really large numbers or really small numbers. So for example, if I have 5 grams of hydrogen, that contains an insane amount of hydrogen atoms. We need a very convenient way to express this, and this is known as a scientific notation. It's just a way of writing either large or small numbers in a very convenient way. Scientific notation has 2 parts. This is known as the decimal part, and it's always you have a number here between 1 and 9, followed by a decimal point. And you can have as many numbers as you want to the right of the decimal point. You can only have a single digit to the left of the decimal point, and it cannot be 0. Then we have the exponent part. Then we're going to multiply it by the exponent, which is going to be base 10 raised to a power of an exponent, right? So it's raised to something. And that exponent means that the number that I have right here is simply multiplied by 10 as many times as we need to. All right. So if I have a positive exponent, so let's say it's 3, that means I'm multiplying it by 10 3 times. If it's 2, I'm multiplying by 10 2 times, and so on and so forth. If the exponent is negative, that means I'm dividing by 10. So if it's negative 3, I'm dividing by 10 3 times, and so on and so forth. And the way we convert and go back between the decimal part and the scientific notation is by moving the decimal point to obtain a single digit between 1 and 9. Then you're going to multiply that decimal part by 10 raised to a power. Okay? And we can do this in one of 2 ways. For example, if the number is greater than 10, like the one I have on the left right here, then I'm going to move the decimal point. In this case, I'm moving it 1, 2, 3 places to get a single non-zero digit to the left of the decimal point, 5.983. So if the number is greater than the exponent, then the exponent is going to be positive. Okay, so the exponent will be positive. And the magnitude, the value of that exponent is going to be equivalent to the number of places that you moved the decimal to the left. Okay? Now let's take a look at this second number right here. If the number is less than 10, then the exponent is going to be negative. Now notice, in order for me to achieve scientific notation here, I need to move this decimal point 1, 2, 3, 4. That 3 is the first non-zero digit that is going to be right here. So I moved it 4 places. Therefore, the exponent is 4. Because that number is less than 10, then this is going to be negative. All right? So maybe in high school, you learned that if you move the decimal to the right, the exponent is negative. If you move it to the left, the exponent is positive. I'd rather you learn if the number is large, the exponent will be positive. If the number is small, the exponent is negative. Much easier that way. All right, now go ahead and try the following. You should pause the video and try to answer all of those, then come back and check your answer. Now I'm going to give you the answer. So now I'm going to move the decimal point 2 places. So it'll be 1.234. Because the number is larger than 10, my exponent is going to be positive. I moved it 2 places, 1, 2, so it's 10 to the 2. In this case, I'm going to move it 1, 2, 3, 4, 5 places. So it'll be 1.45 times 10 to the 5. And here I'm going to move it 1 space. So it'll be 2.525 times 10. And here it stays as is. Your textbook says times 10 to the 0. I'd rather if you don't do that. It makes no sense to do that, so don't do it. 8.0012 stays as is. This one, I'm going to move the decimal point 1, 2, 3 decimal places. So therefore, it'll be 2.34 because the number is less than 10, then, or less than 1, basically, the exponent is going to be negative. So it'll be 2.34 times 10 to the negative 3. And this one, we're going to move it 2 places. It'll be 1.23 times 10 to the negative 2 since the number is small. And this number is small as well. The exponent will be negative. So I'm going to move it 1, 2, 3, 4, 5, 6. So it'll be 8.706 times 10 to the negative 6. All right, now try the following. Now I'm going to give you these values in scientific notation, and I'm going to ask you to write it in standard form. So go ahead and pause the video. And once you have the answers, come back and check here. So all I'm going to do, the exponent is positive. That means I'm going to move the decimal point 3 places. So by moving it 1, I take care of 1. Then I have 2 more. Then I add 2 zeros. So I'll be 2100. 9.66 times 10 to the negative 4. I'm going to move the decimal point to the left. I need a number that is small. If I move it to the left, I need a small number. So it'll be 0.30966. Okay, so I get 1, 2, 3 zeros. The number of zeros you add or when you have a negative exponent is going to be the exponent minus 1. Is always the way because this is non-zero digit. That's how many zeros you will add. So negative 2, that means I'm adding 1 0 after the decimal point. So it'll be 0.0604. Times 10 to the 5, since I have 2 digits here, I need to add 3 zeros, right? 5 minus 2 here will give me 3 zeros. So that'll be 402, then 3 zeros. 3.3 times 10 is 33. 1.2 times 10 to the negative 6. That means I'm adding 5 zeros before the 1 after the decimal. Okay, so that'll be 1, 2, 3, 4, 5 zeros. 1, 2. All right. Now that we understand what scientific notation is, we're going to be using scientific notation in calculation. So I just want to review with you a little bit how we use scientific notation in multiplication, division, addition, and subtraction. So first, let's take a look at how we use it in multiplication. So when multiplying numbers written in scientific notation, what you do is you multiply the first factors, then you're going to add the exponents. Okay, so for example, I have 3.2 times 10 to the negative 3 times 2.1 times 10 to the 5. So all I'm going to do, I'm going to multiply 3.2 times 2.1, these two. Okay, so I multiply 3.2 times 2.1. Then I'm going to add the exponent. Minus 3 plus 5 will give me 2. So the answer will be 6.7 times 10 to the 2. All right? Okay, so the rule would be if I have 10 to the A times 10 to the B should equal 10A plus B. That's the rule. Now, when it comes to division, we subtract the exponent rather than adding. Okay? So, for example, I have to divide here these two factors, right? So I'm going to divide 6.4 by 1.7. Then I'm going to subtract the exponent, 6 minus 2. So I get 3.8 times 10 to the 4. So the rule here is going to be, if I have 10 to the A divided by 10 to the B, then will be 10A minus B. All right. And as a bonus, if I'm actually raising to the power, so if you have 10 to the A raised to the B, that will equal 10a times b. All right, and if I take in the root, whatever it is here, of 10 to the a, that would equal 10a divided by x. Okay, those are the rules. Now one more, and that would be addition and subtraction. In order to add or subtract numbers written in scientific notation, you must express both of them to the same power of 10 first before you can add them or subtract them. Okay, this is important. So for example, I have these two numbers that I need to add, 5.8 times 10 to the 3 and 2.16 times 10 to the 4. Notice that the exponents are not the same. I can't just simply add the numbers. I should express both of them, either 10 to the 3 or both 10 to the 4. So let me do it both 10 to the 4. So I'm going to write this instead of 5.8 times 10 to the 3. Even though it's not correct scientific notation written, I'm going to write it as 0.58 times 10 to the 4 plus 2.6 times 10 to the 4. So now I can add these two. So it'll be 2.16 plus 0.58 will be 2.74 and simply times 10 to the 4. All right. Hopefully this helps.